This last section of Unit 6, we're going to perform similarity transformations. Dilations are similarity transformations. They shrink or stretch a figure to create a similar figure. In this dilation, a figure is enlarged or reduced in respect to a certain fixed point, which is called the center of dilation. The scale factor of a dilation is that ratio I'm going to highlight this for you, is that ratio of a side length of the image to the corresponding side length of the figure. In this particular figure, the center of dilation is 0, 0, and the scale factor would be xy over AB. We have coordinate notation for dilations. Coordinate notation is, we say xy such that kx, ky, and that k is the scale factor. If it is between 0 and 1 or a fraction, it's a reduction. If it's greater than 1, it's an enlargement. So you can tell if you're going to have an enlargement or a reduction just by looking at the scale factor. Okay, we're going to draw a dilation of a quadrilateral with vertices 0, 3, 2, 3, 3, 1, and 2, 0. So there's my quadrilateral, and my k is 3. So to find my image, I just multiply that by both vertices, or both coordinates. So I want 3x and 3y. So A prime would be 0, 9. And D prime. So all I did was multiply both coordinates by 3. So A prime 0, 9, 6, 9, 9, 3, and 6, 0. And there is, and this would be an enlargement. The 3 is greater than 1, so this would be an enlargement, and that truly is what it looks like. So find the coordinates of L, M, and N so that the triangle is a dilation of PQR with a scale factor of K. Okay, so in 2, this is going to be the same thing. This is going to be a reduction, so the numbers should get smaller. So 5 times 0.4 is 2. 10 times 0.4 is 4. Okay, so finding a scale factor. You want to reduce the size of a photograph to the height shown. What is the scale factor of the reduction? So scale factor is going to equal the side length of the image. So that's the reduction or the enlargement over the side length of the original. Okay, so my image is 3 inches. My original is 8.5 inches. And you don't want to leave that in a decimal and a denominator or a fraction. So that equals 6/17. So you should try number 3. Okay, so it's the image, which is the new side length, over the original. So you should, because it says it's a reduction, you should definitely get a fraction. Reading diagrams, so generally for center of dilation at the origin, a point of the figure and its image lie on the same ray from the origin. However, if a point of the figure is the origin, its image is also the origin. So just looking at this, you want to see that from the dilation from the origin, it's the same ray. So you're following these black lines and see that every point of the vertex lies on the same ray. So we're going to find points of dilation. We want to create a quadrilateral ABCD that is similar to a quadrilateral FGHJ. What are the coordinates of D? So basically you want to know what is the last set of coordinates for D. And if you do the method, and I can't draw straight lines, if you do their method of following the rays from the origin, then I know J so D is going to rest over on this side. How can I do that? I can easily just find and see what the factor is. So I'm going to just look at coordinates of F are 0, oops, helps if I write it right, are -1, 0, and A is -4, 0. So -4 divided by -1 is 4. So that's my K. So you just take the coordinates for J, which is -2, -4, and multiply it times 4. And that should work. Let's see, 1, 2, 3, 4. 2, 3, 4, 5, 6, 7. Oh, they don't want to have you draw it, so that is done. And this one, what is the scale factor? We can just look again at a set of coordinates. So I'm going to look at G, which is 1, 2, negative 3, negative 1, and B, which is 1, 2, 3, 4, 5, negative 6, negative 2. Negative 6 divided by negative 2 is 2 to 1. So the scale factor is 2. And then D and E. D is going to be from J. J is 1, 2, 3, 1. So this is going to be 6, 2. And K is 1, 6. So E is going to be 2, 12. And that ends dilations.